Welcome to another Mr. Paul video. Today we are building on one-step equations with two-step equations, okay? If you haven't watched the video with one-step equations, I strongly encourage to go back and watch the one-step equations video, or at the very least watch the Khan Academy video. Otherwise, this two-step equation won't make a whole lot of sense, okay? So in the two-step equation, what we're saying is we're still trying to find for an unknown number, which is x. But in this time, it'll take two of those basic operations, those basic tools, to be able to solve for what that missing value of x should be. Okay, so before we go much further in our understanding of algebra, I decided to list out some goals that we should be trying to accomplish when considering algebra, when considering where should we go first. As these equations become more complex than the previous examples that we've seen in the video, where just one step was necessary, we have to start to redefine what we're trying to do. I'm not listing these as rules for a reason, okay? Because rules imply that you do this every single time. You could think of these like rules, but I'm listing them as goals instead because I want you to understand that this is going to be the hardest part of algebra. And that is that not every problem, not every single example is going to be the exact same. So every step that you're supposed to follow, some can be skipped, some require some additional work. But the basic premise, if you can get these three goals accomplished, you can solve the equation. You can solve for the unknown number, the variable, okay? So in all of these examples, we're trying to accomplish these three goals. And in each step, I'll describe how these three goals are being met at each step of the way. The first goal is we want to get all of the variables onto one side of the equation. Now, just to remind ourselves, what are variables? Those are things that have to do with x. So such examples are this number here, 5x. 5x is a variable. In this example, 2x is a variable. In this example, negative 2x is a variable, and 3x is a variable. In this example, we have 5x as a variable and 2x as a variable. Anything with an x, you can call a variable. All of the constants on the other side of the equation. Okay, and the constants, we can think of those as the regular numbers. Okay, those are numbers that we're used to seeing, like on this number line. There's nothing special about them, there's no x, but examples are like this -2, this 8, this 3, this 11, this 3, this 9. Those are examples of constants. So just to reiterate what these first two steps are saying, and to put it as basic as I can, these first two steps have everything to do with I have variables and I have constant stuff with x and stuff that don't. And they're going to be on one or both sides of the equation. And my job in these first two steps is to separate them. I want x's on one side, and I want the variables of x on one side, and I want the constants on the other. And it doesn't matter if the variables are on the left, the constants are on the right, or if the constants are on the left and the variables are on the right. And it just depends. Okay? You'll find out that it doesn't matter which side. It doesn't matter because remember, the sides of a scale don't matter. So in each of these cases, I'm going to be trying to think ahead to how can I separate them the easiest? Okay? While there's lots of different options I can choose, I see stuff being multiplied, I see stuff being subtracted, I see a positive number. I see another number being multiplied, I see another positive number. I have lots of things, and I'm not sure which way to go first. As long as I keep these three goals in mind, I will be in great shape for success. Okay? So let's remember that these three goals are in mind, and I'm going to start with the first goal, continue with the second, and then try the third goal. So in this first example, my first goal is to get the variables onto one side of the equation, which means in this equation, separated by the equal sign, I want all of the things with x on the left, or I want them all on the right. I do not want them on both sides. You will notice that the stuff with the variable is on the left, and there's none on the right. This first goal is already accomplished. I don't have to do anything extra. So I can, in my mind, I can check that off. I can say, okay, this goal has been met. The variables are on one side. Get all of the constants onto the other side, meaning the regular numbers, meaning this -2 and this 8. I want them onto the other side, the opposite side of the equation. So if my variables are on the left, I want my constants on the right, which means I do not want this -2, this -2 on the left. I want it on the right. So if I follow this goal, the variables are on the left, I want my numbers on the right. I don't want this 2 here. It's being subtracted. So if it's being subtracted, I'm doing the opposite operation, which is to add. If you are not sure what I'm talking about, you didn't watch the previous video, I'm going to add 2 to both sides. I'm going to use an inverse operation to both sides of my equation. If I do, I can maintain that both sides remain equal. Similar in a way in the previous video, you add 2 to one side, it becomes unbalanced. You add 2 to the other side, it balances back out. Okay. If I add 2 to this side, these 2's cancel. 5x is left on this side. And that's going to be equal in value to 8 plus 2, which is 10. Now I can think of this as a brand new scale. On one side I have 5x, and on the other side I have 10. 5 times some unknown number is equal to 10. This should be familiar from the last video. If I have two things being multiplied, I now have I should take a step back. I now have all of the constants on one side and the regular numbers on one side and the variables on the other. The x's are on the left, the regular numbers are on the right. You'll notice that this step eliminated it from the left-hand side. Now I will continue with my last. Usually you're going to multiply or divide to get down to 1x, just like we did on the one-step examples. So I have 5 x's and I want to be just 1x, right? 1x. So I see a 5 times an unknown number, 5 times that. So I want to divide by 5. If it's being multiplied by 5, I divide it by 5. I'm going to divide both sides by 5 to maintain that both sides are equal. 5 divided by 5 is 1 times x. 10 divided by 5 is 2. And I'm claiming that x is equal to 2. If x is equal to 2, it's like saying 5 times 2, which is 10. 10 minus 2. This side is equal to 8. This side is also equal to 8. In the second example, you'll notice that we have the variables also on the right, but we have constants on the left and the right. The first goal is already met. The variables are on one side. They're on the left, which means I want my regular numbers on the right. I don't want this 3 here because that's the side I've decided my variables are on. So I want to take it away. This is positive. I'm going to subtract 3 from this side of the equation. Whatever I do to one side, I have to do to the other to maintain that both sides are equal. If I take away 3, these cancel, and I'm left with just plus 2x or positive 2x. 11 minus 3 is 8. I have 2 times some unknown number, okay, is equal to 8. You'll notice the variables are on one side, the constants are on the opposite side, and now I want to multiply or divide. Typically, you're going to multiply or divide. These are being multiplied, so I will divide. 2 times the number, so I'm going to divide by that 2 and divide by 2. 2 divided by 2 is 1 times x, and that's equal to 8 divided by 4, or 8 divided by 2, which is 4. What this is saying is x is equal to 4, and I can check my work. I'm saying if x is equal to 4, if this unknown number is a 4, it's like saying 4 times 2, which is 8. 8 plus 3 is 11. This side is equal to 11. This side is equal to 11. They are equal to each other. This is going to be a little bit more troubling, but not really. But not really. Okay? So let me show you what I mean. The process remains the same, even though the answer will look strange. Okay? I need to get my variables onto one side of the equation. You'll notice I have variables on the left and variables on the right. I want them onto one side. I also want to have constants onto one side of the equation, opposite that of the side that has the variables. So if I have constants that are just on the left, but variables on both sides, the least amount of work would be if there's already constants on one side, why don't I just move the variables to the other side? Meaning I don't want this 2x here. It's being subtracted, so I'm going to add it, 2x. Remember, if you're taking away stuff with variables, you have to take away all of the stuff, meaning the variables as well. If I'm adding 2x's, if I'm seeing a subtracting 2x's, I'm going to add 2x's. Whatever I do to one side, I'm going to do to the other. If I added 2x's to this side, I have to add 2x's to this side. These cancel just the same way that the numbers did. Remember, x's are just unknown. That doesn't mean we can't do mathematical operations with them. Because I did the same thing to both sides, I could say that both sides still remain equal. 3 is what's left on the left, and 3x plus 2x is 5x. 5x's is equal to 3. I don't want 5x's, these are being multiplied. I want to divide by 5 and divide by 5. 1x, right? 5 divided by 5 is 1, is 3 over 5, the fraction, or I could think of this as 0.6. And I'm okay with either of those. Now, it is a little bit harder to check the math on it, but it's okay. We know that x is equal to 0.6. Do all answers work out strange? Well, no. I have variables on the left, variables on the right, and a constant on the right. I want to get the variables onto one side, and I want to get the constants onto the opposite side. Well, the least amount of work would mean if I only have constants on one side, it would make sense to move the variables to the other. So I want to get rid of this positive 2x. I want to get rid of this. So if it's a positive number, I want to subtract it. I want to take away 2x from this side, and to make sure it's equal, I'll take away 2x's from this side. If I do that to both sides, I can maintain that both sides are equal. 5x take away 2x is 3x. 2x take away 2x, they cancel, and just 9 is left. I've accomplished the first two goals. Variables are now on one side of the equation where they were on 2. The constants are on the opposite side of that, which it is. Those first two goals are met. But you'll notice that these steps in these first two examples versus the second two are not exactly the same. But the goals are being accomplished. So I know I'm going the right way. 3 times some number is equal to 9. I don't want 3, I want 1. So if it's being multiplied, I will divide. I'm dividing by 3 because it's being multiplied by 3. 3 divided by 3 is 1x. As long as I do the same thing to both sides, I can maintain that both sides are equal. 9 divided by 3 is 3. What this is saying is when x is equal to 3, both sides will be equal in the original equation. And we can check. If x is equal to 3, 5 times 3, this side is equal to 15. If x is 3, what is the value of this side? Well, it's 2 times 3 plus 9. 2 times 3 is 6. 6 plus 9, this side is equal to 15. This is 15, that is 15. Left is 15, right is 15. Only when x is equal to 3. The unknown number to make both sides equal is 3. The goals are going to be the hardest thing for you to get your head around. And the only way to solve it is to keep doing more and more examples. Here's 4 of them. Okay? Be patient, keep practicing, and algebra will start to make more sense the more practice we do. That's all for today's video. Peace.